Hello everyone, this is Mr. Ahmed and today we'll do lesson 1.2, recognize proportional relationships in tables. So our objective today is to identify proportional relationships in tables and equations. Identify the constant of proportionality and write the associated equation. So our two main vocab here is proportional relationship and constant of proportionality. Okay, spark your learning. So page 11, let's start with this problem. For which tables can you predict the cost of 100 units of the item? Explain why you can make that prediction for some of the tables and not for others. For the tables that let you predict the cost of 100 units, find the cost. So we will have here 4 different tables. Peanut butter with total cost, binder clips with total cost, trail mix with total cost, shower sponges with total cost. So in order to predict the 100 units of the item, guys, we must have here equal ratio or we have something called proportional relationship. Okay, so we can get the cost of one and then just multiply it by 100 to get the cost of 100. But if the table shows relationships that they are not proportional, the ratios are not the same, we cannot predict the total cost of 100. So let's see each table. So the first table here, peanut butter with the total cost. In order to see this table represents proportional relationships, we can just divide the two numbers here or the two columns here. So for example here, 8 divided by 3, it's like 8 over 3, which is like 2 and 2/3. Okay? If you do 16 divided by 4, that will be equal to 4. So 16 divided by 4 equals 4. So it's clear here, guys, that this is not proportional relationship. Okay? So peanut butter with total cost, we cannot predict the cost of 100 units. But let's look here at these numbers. So if you buy 8 ounces, you will pay $3. If you buy 16, which is double of the 8, you will pay only 4. So you increase or you double the number of ounces and you only increase $1. So it seems here when you buy more ounces, the price per ounce gets less. Okay? So it's like we have a discount here. When you buy more, you save more. Okay, now let's see the binder clips and the total cost. Okay, easy way here. Divide 12 divided by 2, and that is equal to 6. So we can say 12 divided by 2 equals 6. 36 divided by 5. The close thing is 35. So 35 divided by 5 is 7. And we have 1 remaining. So 7 and 1/5. And 50 divided by 6. Actually, we don't need. You don't have here the same ratios, so you can stop here and you say these are not proportional. Okay? The same thing here when you buy more. So for example, if you buy 12, you will pay $2. But if you buy 36, which is triple, you should pay here 6. No, but you just pay 5. So it seems like also when you buy more binder clips, you save more money. But still, the first two tables here, the binder clips and for the peanut butter, they are not proportional. Let's see this one, the trail mix with the total cost. Okay, so, I would like to divide the big numbers by the small numbers. So what if I divide the 6 by 2? So 6 divided by 2, let's make it as a fraction. So 6 divided by 2, it's equal to 3. Also 24 divided by 8, it's equal to 3. 36 divided by 12, it's equal to 3. So you can see here that the ratios are equivalent. So we can say, yes, this table represents proportional relationship. So trail mix with the total cost, we can predict the cost of 100. So guys, here we have $6 for 2 pounds. So when we divide 6 by 2, you get 3. This is like, let's move it a little bit here. This is like $3 per pound. So the cost per pound, 1 pound costs $3. So 100 pounds will cost $300. Shower sponges and the total cost. Let's do the same. We divide the 8 by the 4. So if you divide the 8 by the 4, you will get 2. You divide the 16 by the 8, you will get 2. You divide the 20 by the 10, you will get also 2. So it seems here the ratios are equivalent. So we have proportional relationship. And hence we can get the cost for one sponge. So here 8 divided by 4, it's 2. So it's $2 per sponge. So if you need 100 sponges, that will be $200 for 100 sponges. So what we can write here, guys, we can say that 100 pound of trail mix costs $300 because $3 per pound, but 100 shower sponges cost $200 because it's $2 each, or $2 per sponge. But for the peanut butter and the binder clips, they cost less per unit when you buy more. Okay, so you get discount when you buy more. Okay, let's connect this to the vocabulary. Two quantities have a proportional relationship if the ratio of one quantity to the other is a constant. So you give the ratios like we did before. We found that all the ratios equal 3. So we say that the quantities here have a proportional relationship. So the unit rate that we get, we call it the constant of proportionality. So what is the constant of proportionality? It's always you divide the y by the x. So when you divide the two quantities and the answer is always the same, or the ratios are all the same, they equal to something, that thing we call it constant of proportionality. And we usually represent it by the letter K. Let's look at this example. Maxine walks dogs to earn extra money. The table of values shows the proportional relationship between the number of dogs Maxine walks and the amount of money she earns. We have up here the dogs walked and down here the amount, the money. So if she walked 2 dogs, she gets $7. If she walked 4 dogs, she gets $14. And if she walked 6 dogs, she gets $21. So question A, it says, show that the ratio of dogs walked to amount earned is a constant ratio. So let's look at the first column, dogs to amount. So we need to divide the dogs, the number up, by the number down, by the money. So it's 2 over 7. So always dogs up and money down. Okay? So this is the first ratio. The second ratio also is 4 to 14. And you know, when you simplify fractions, you can just divide up and down by the same number. So 4 divided by 2 and 14 divided by 2. Both numbers can be divided by 2. So 4 divided by 2 equals 2, and 14 divided by 2 equals 7. What about 6 to 21? It's the same thing, but both numbers can be divided by 3. So when you divide by 3, you'll get 2. 6 divided by 3 is 2. 21 divided by 3 is 7. So as you can see here, all of the 3 ratios are equivalent. They are 2 to 7. So the ratio of dogs walked to amount of money earned is always 2 to 7. Question B. Show that the ratio of amount earned to dogs. So here, guys, it seems to be the opposite. Okay, so we need to divide not the 2 by the 7. No, we need the money divide by the number of dogs. So instead of we divide 2 by 7, no, we divide the money first. So 7 divided by 2, or 7 over 2, okay, which is actually equal 3.5. And if you do the rest, 14 over 4, you'll find that it's equal to 7 over 2 also, or equal to 3.5. And also you can find that 21 over 6, the same thing, it's equal to 7 over 2, or it's equal to 3.5. So let's say that all of them, they are equal to 3.5. So that's 3.5, or $3.50 per dog. Okay, question C, it says, what is the unit rate of dogs walked per dollar earned? Does it make sense? And explain. Here we need the unit rate of dogs per dollar. So we need to divide the number of dogs by the number of dollars. So which question was related to this, A or B? A, because it was dogs to dollars, okay, to money. And when we get the unit rate, it's like you divide the number of dogs by the amount of money, which is actually the same, 2 over 7. So it's a 2 over 7 dog per dollar. But does it make sense? 2 over 7 dog? 2 over 7, guys, it's a fraction. Okay, so imagine that there is one dog. Can we cut it into 7 pieces and we take 2 pieces only? No, we cannot cut the dog, or cannot get a fraction of a dog. So it makes sense? No, it doesn't make sense. So we say that 2/7 dog per dollar, and we can say no because you cannot have a part of a dog. We cannot have a fraction of a dog. Okay. Question D. It says, what is the unit rate of dollars earned per dog? So it seems here to be the opposite. Okay, so here we need money divided by dogs. And this is what we did in question B. We divide the money by the dogs. When we divide the money by the dogs, 7 divided by 2, it's equal to 3.5. So it's a $3.5 per dog. And we have no problem for the 3.5. The 3.5, we can have the money in fractions, no problem. It's a $3.50. There is no problem in it. So we say $3.50 per dog, and money can be shown as decimal, no problem, or fractions, no problem. Here, what is the constant of proportionality? K in this situation. Okay, so here the constant of proportionality is the number we get when we divide the money by the dogs, y by the x, the number down by the number up, and that is 3.50. So we can say that K equals 3.50 or 3.5. Okay, F, describe what the unit rate K represents in this situation. So that 3.50, it represents what? It's the money. 3.50 is the money we get when we divide the number, when we divide the amount by the number of dogs. So we divide it by the number of dogs, it means that is the cost for one dog. Okay, so this is the money Maxine gets when she walks one dog. So we can say that that is the price Maxine charges to walk one dog. Okay, step it out. Question number 2. Two relationships are represented in tables. Which table shows a proportional relationship and which doesn't? And explain. Table 1, what do you see here? Windows washed, that is the X, and the amount earned, that is the Y. Okay, let's agree to something, guys. You will start to see X and Y in most of the questions now. And usually X is up and Y is down. So always, to know that the table represents a proportional relationship, you need to divide the values of Y by the corresponding values of X. So always divide the Y by the X. If you get the same ratio, if you get the same answer for all of them, it means we have here proportional relationship. Okay, so all of these, we divide the Y, the money, by x, which is the windows. So 36 you divided by 3. And 36 divided by 3, that is equal to 12. The second one, 72 divided by 6, and that is equal to also 12. And 84 divided by 7, and that is also equal to 12. Here it says the ratios y to x are or are not equivalent. They are all equal to 12, so they are equivalent. Equivalent means equal, guys. Okay, so all they are the same ratio. Therefore, the relationship shown in this table is or is not proportional. It is proportional. This is from the definition. If the ratios are equivalent, or the ratios of y to x are equivalent, so we have proportional relationship. Let's look at table 2. Also, windows and money, x and y, always divide the y by the x. So 48 divided by 4, and that is equal to 12. Then you will have 55 divided by 5, and that is equal to 11. And 64 divided by 8, and that is equal to 8. If you focus here, you can find that they are not equal to the same number. So the ratios y to x are or are not equivalent. Sure, they are not equivalent. They are not equal to the same number. Therefore, the relationship shown in this table is or is not proportional. Sure, it is not proportional. So the ratios are not equivalent, so the relationship is not proportional. Okay, example 3. The number of students whom Malcolm tutors is proportional to the amount earned. The calendar shows Malcolm's earnings from tutoring in 1 week. Okay, so here it says it's already proportional, so we are not searching for proportionality here. Okay, we need first to complete the table. So number of students, it's x, and amount of money earned, it's y. So let's look at the table here. So this is the tutoring schedule, and you can see on Monday, Malcolm had like 1, 2, 3, 4 classes, and the total amount is 120. So this is 4 classes and got $120. So let's look at the table. Yes, here's the $120. So up here should be 4. On Tuesday, it's 1, 2, 3, 4, 5, 6 classes, and the total amount is 180. So 180, we'll put here 6. And on Wednesday, 1, 2, 3, which is 3 classes for 90. So 3 classes for 90. And Thursday, 1, 2, 3, 4, 5, and it's $150. So 5, 150. And Friday, it's only 1 class for 30. So one student. So here these are the students, guys. Okay, so 1 student for $30 here. Okay, letter B, it says find the constant of proportionality. Always y divided by x. So k is y over x. So it's like you take any number in y and you divide it by the corresponding number in x. So you can do 30 divided by 1. This is the easiest one. And it's equal to 30. If you try, for example, 90 divided by 3, it's the same. If you try 150 divided by 5, it's the same, 30. Okay, so you can pick anyone here. It's fine to use 30 divided by 1 equals 30. Okay, here we have something new here. The equation for a proportional relationship is y equal kx. Okay, so the relationship is between y and x. And k here is the constant of proportionality. So where k is the constant of proportionality. Okay, so you just divide the number down by the number up. You got the k. You can write the equation. So use the value of k you found in part B to write an equation for this proportional relationship. So y equal kx, and k here is 30. So put here 30x. So always when you see an equation like this, it means we have proportional relationship. Okay, question number 4. The equation y equal 12x. Oh, like I said now, y equal 12x. It seems like it's like y equal kx. Okay, so it represents the number of inches y in x feet. The equation y equal 12x does or does not represent a proportional relationship? Sure it does. Okay, it's the same like y equal kx, where k here is 12. Okay, so y equal 5x, y equal 3x, y equal 10x. All of these are proportional relationships. Okay, represent a proportional relationship? If so, what is the constant of proportionality? We just said it. It's the 12. How do you know? Because it's in the form y equal kx. So we can say the constant of proportionality is 12, and the equation is in the form y equal kx while k equals 12. B, use the equation to complete the table of values for the relationship between inches and feet. So here feet, the x, inches, the y. Remember the equation is y equal 12x. What does mean 12x, guys? It means 12 multiply x. So you take the x multiplied by 12, you get the y. So here, for example, we have the x. X is 0. How you get the y? You just multiply it by 12. So 0 times 12 is 0. 1 times 12 is 12. 2 times 12 is 24. So you multiply the x by 12, you get the y. Okay, here, what is the number times 12 equal 36? It's 3. 3 times 12, guys. 3 times 12 equals 36. 4 times 12 equals 48. And 5 times 12 equals 60. Okay, let's check our understanding. Try to solve these questions, guys, okay? So, here, there are 4 quarters in $1, okay? 4 quarters in $1. Make a table of values to represent the relationship. Okay, so we have here x the dollars, y the quarters. So which information do we have? 4 quarters and $1. So x is the dollars, it's 1. Y the quarters, so it's 4. And we can get more. We can say, for example, $2 has how much? $3, $4, $5. So if $1 has 4 quarters, $2 has 2 times 4, it's 8. 3 times 4, it's 12. 4 times 4, 16. 5 times 4, it's 20. So 4 quarters in 1. This is, guys, like the unit rate here. Okay, this is the constant of proportionality. Okay, so you have four quarters for $1. Okay, he says here in question B, is this proportional relationship? Sure, we are multiplying all by 4. Or if you divide the y by the x, if you stick with this rule, guys, if you divide the y by the x, always when you do 20 divided by 5, you get 4. 16 divided by 4 equals 4. 12 divided by 3 equals 4. 8 divided by 2 equals 4. 4 divided by 1 is also 4. So this is sure proportional relationship. And if so, identify the k, the constant of proportionality. And it's clear it's the 4. When you divide y by x, you always get 4. So we can say yes, and it's k equals 4, represent the number of quarters in $1. Okay, and so this is like the unit rate. Write an equation for this situation. Okay, the equation is really easy, guys. Always the equation is y equal kx. Just erase the k and write its value. Here the k is 4. If you don't know how to find the k, just divide the number down by the number up. 20 divided by 5. 16 divided by 4. Or it's really clear here, 4 divided by 1. So you can get it by dividing like this, or you can say it's the unit rate. It's for one item. Okay, so here $1 has 4 quarters, so the k is 4 here. Hope it's clear, guys. Okay, so question number 2 here. The equation y equals 7x gives the cost y of x pounds of chicken at a grocery store. Complete the table for the given weights of chicken. So here the weight, and it's x, and the cost, which is y. So here it says y equal 7x. It seems you multiply the x by 7 to get the y. So let me write it. Multiply x by 7 to get y. Okay, so up here we have the x's just multiplied by 7. 1 times 7 is 7 to get the y. 2 times 7 is 14. 5 times 7 is 35. 8 times 7 is 56. Question 3. Is the relationship in the table proportional? If it is, write its equation. Okay, to check if it's proportional or not, always do y divided by x. So you do 5 divided by 1. So 5 divided by 1 equals 5. 10 divided by 2 equals 5. 15 divided by 3 equals 5. 20 divided by 4 equals 5. So you see here, all the ratios are equivalent. Okay, they are equal to 5. So we can say yes, the ratios are equivalent. So that the table here has a proportional relationship. How to write the equation? When we divided the y by x, we got 5. It means the k equals 5. And the equation is y equal kx, but instead of k, we put 5. So y equals 5x. Okay, now your turn, guys. On your own questions, try to solve these questions alone, then resume the video to see the answers. And that is more practice and homework. I hope you solve it, guys, and I'll send you the answers later. Okay, that's it for today, guys. Hope you enjoyed this lesson. Bye.